I work here with my graduate students in the Clean Energy Research Center, and we're interested particularly on about combustion in engines and increasing efficiency, reducing emissions from internal combustion engines. In my group, we're looking at efficiency and emissions from internal combustion engines. We're particularly interested in natural gas engines.
My research specifically deals with trying to extend the lean limit of combustion. So what we have is we have an engine that is running with more air than fuel than it would normally run with, and what happens is that becomes hard to burn. So we're trying to add a little bit of fuel right near the spark plug, and that allows for better combustion.
Well, currently I've been doing work with fuel cells on the side, and so I've been working in water management.
Okay, my name is Hubert Ahling. I'm from Freiburg in Germany, and I'm working at water management in polymer electrolyte membrane fuel cells. I mean, there are a lot of applications to fuel cells. I mean, one main application is the automotive industry, and Germany is very big in the automotive industry, so they have a great interest also in the hydrogen fuel cell technology.
So I study microfluidics, which is very tiny fluid flows. So imagine like a pipe that's the size of a human hair. Those are the type of things I look at. What we do is we create a mold up in the clean room to make very small devices. We pour a polymer onto this mold, let it cure, and then we use that to create a device where we sort cells. So we put cells into tiny channels and then we separate them from each other. So this is really important because we're looking at things like diagnosing cancer, looking at circulating tumor cells. So this is of really high interest to the medical community.
Generally, I'm working on different injection strategies in natural gas engines, and I want to see the effect of different injection strategies on the soot emission. One of the major emissions is the soot in engines, and we are trying to reduce the soot in natural gas engines.
Basically, we would like to improve air quality in buildings and at the same time reduce the energy consumption and improve the healthy environment that people are in. We have a lot of cameras and high-speed imaging equipment, as well as other sophisticated equipments based on laser technology to measure aerosols, basically fine droplets in very, very dilute concentrations.
My name is James Montgomery. I'm a first-year PhD student and I study fluid dynamics. The research that we do in the lab is important because it's focused on energy reduction and efficiencies in both the rail industry and in the pulp and paper industry, which are fairly important.
In this lab, we measure power for different rotational speed, different gap size, and different flow rate for pulp with different consistency. And we have several different refiner plates with different bar and groove geometries, and we wanted to know what's the effect of this geometry on pulp properties and also the energy consumption inside the refiner.
The goal of my project is to reduce energy consumption in paper recycling. Okay, I actually built my own machine to accomplish my research. It's called a repulper. It's like a giant blender. It's the first machine in any paper recycling operation. Even a smaller repulper here in British Columbia, where electricity is cheap, can cost $200,000 a year to operate just in electrical costs. So if I can improve the efficiency of the machine, that's savings for the environment and savings in costs for the people who operate these, which are essential machines.